Good afternoon, this is Schweitzer, a little video on the answer key for our practice acid-base test. Alright, start looking through the answers here. All things that are acidic eventually produce, one way or another, via hydrolysis, H3O plus ions. Now, there are a couple different ways in which that works, but the main one is through a hydrolysis equation. You should be able to write out generic hydrolysis equation. And there we go, producing H3O plus and X negative. Strong and weak, same thing. All things that are basic eventually produce hydroxions. This HNO2 is an oxyacid, which the following is the describe the name. That would be nitrous acid, which the following acid contains is considered the strongest. All right. Now, strength is how much this reaction proceeds to products. Strongs go 100% to completion, and for that matter, only represent products in models, but weak ones are typically more reactant favored, considerably more reactant favored. That being said, we describe the ratio of the products over reactants at equilibrium, products over reactants, as a K value. So one of the larger K value means more strength. A larger K value equals strength. That doesn't mean you can neutralize more, it just means that you get more at once. So -3, -7, -10, -12, the largest one would be, again, solely based on the K value, not the concentration. A 0.1 molar HCl solution is titrated against an unknown NaOH solution. 10 milliliters of 0.1 molar HCl is required to reach the equivalency point of 10 milliliters of NaOH. What's the concentration of this? Well, we've done a bunch of these already. Hopefully it's not the first time you see these, but the volume's the same in the known unknown table. Unknown. If the volumes are the same, then the concentrations are the same and the moles are the same. So this has to be, if this is 0.1, this also needs to be 0.1. 10 milliliters of 0.1 molar NaOH is required to neutralize 20 milliliters of HCl. So it takes, to get the same number of moles, this is the same number of moles in twice the volume, so it's half as concentrated. 0.1, it is 0.05. I'm just taking the way that I would solve that problem. You're more than welcome to step a known, unknown table and solve it out. Molarity, moles, liters. And you should be able to do that. Maybe you got to do this a few more times before it starts to really get the big picture. But there you go. What are the products of neutralization reaction between this guy and this guy? So it's just going to be, I'll put it right here, H, what's that, H? HCl plus LiOH yields H2O plus LiCl. And therefore my products are going to be these guys right there. Caffeine is a weak base. In which pH range does caffeine test? Okay, so this is a sort of a qualitative answer. Which general range is weakly basic? Be in this range right here. Stronger bases, weaker acids, strong acids. Next up, okay. Now again, for this last one here, to get the pH, just so you know, there are two things that have an effect on this. One is the concentration of the acid or base, and two is the K value or the strength. Now, strength, okay, they both play a role. Sometimes strength can really be dominating. So you might have a very weak strength. So the concentration can have an effect on the pH. But you could have an acid or base that's 10,000 times weaker. Would you be able to raise the concentration 10,000 times? Maybe not. So a lot of times the Ka value does give the general range of pH. All right, next one. All right, so in the graph above, what is the equivalence point of the curve? This was mentioned in a video. Okay, it's not something we're going to see a lot of, but it's a pretty simple video. And when we're at when we're dumping an acid into a base or a base into an acid, and we're tracking pH, when we reach equivalency, it would be when we have, if we have H plus, let's put two of them in here, anions, and we have OH negative, OH negative. Dump these in, and when the moles of the two are equal, moles of H plus equal the moles of OH negative, then we're equivalents. And you'll see that essentially we've wiped out all of the acid or base. So I'm actually going to dump the base into this guy, and I'm going to throw a pH meter in here, and we'll see it marks out very, very acidic because there's lots of acid. As soon as we match them, the acid's gone, and we flip from acid to a base, and we get a spike here. So right at the spike is where our equivalency is, and it looks like it's right around 100 milliliters. This isn't always the easiest to see. Next page. All right, a solution who is neutral, which of the following must be true? If you're neutral, these two must be equal. If a solution has a pH of 1, the pH is 13. So pH plus POH equals 14. If the solution of POH is 1, is considered what? Well, the POH is 1, then the pH equals 13. 13 on the pH scale is basic. Phenolphthalein is all the following except. Okay, so neutral. Yes, it is not acidic or basic, because that would be a problem if it's trying to test acidic or basic. Chemical indicator, yes. Pink in bases, yes. Greenish yellow in acids. No, it's actually clear in acids. The Ka for hydrochloric acid is, well, we have our reaction, which is HX, or HCl, plus H2O yields H3O plus X negative. So the Ka value for this guy would be the Ka value, the K expression, would be the concentration of H plus ions, this guy, times X negative, divided by concentration of HX, and the water is a pure liquid, so it's not included. And it goes 100% in this direction. So with those products, they everything goes from here to here. So this thing is extremely large. Quite often we don't even list it, just being very large. Therefore, D is the answer. Goes to completion. Ammonium is well-known weak acid. Ammonium is a well-known weak acid. There it is. Which of the following would be the hydrolysis equation for ammonium? And it is this guy right there. Take a look. Number 16. Now, here we go. This is an equilibrium chart. Which of the following is not true? The reaction goes to completion. That's not true. Let's just read the rest of them and make sure. The reaction is product favored. Yep, we have more products than reactants. The reaction is K value greater than 1. Yes. The reaction has both forward reactions running at all times. Yes, even in the end it still runs. So A is the answer. You need to have a limiting reactant. Something got to go to 0 on this thing to be completion. Which of the following is not a strong acid? HF is not a strong acid. There are 6 strong acids: HCl, HBr, HI, HNO3, HClO4, H2SO4. All right. Which number of which number from the titration curve would demonstrate the picture above. All right, so let's see what we got here. So we know that we started out, we're adding base, so it starts out acidic. So my beaker starts out with a lot of acids, and then I keep basically taking my H plus, and we're let's say let's call it HX, and I'm reacting it with our base to produce water molecules and X negative. Okay, so when we reach equivalence, which is at this peak right here, then all of this, that means this guy went from some initial amount to 0. And all I would have, let's say I had 10 of these guys here, then I would have 0 of these to start with, and I would lose all 10. I would be having 10. And the water is just everywhere, so they aren't showing it. So notice here that we have lots of this. So it looks like we're almost completely neutralized. Now, this is the point where we are completely gone. This is the 1/2 way point, where it means that we have like losing 5, having 5 left, gaining 5, and having 5 left. This would be now like marker number 2. So we are not at 2. We're well beyond a 2. In fact, we are about as close to this point as we can be, but we're not there yet because we have 1 left. So the best probably option would be 4 for neutralizing as we roll through. Okay, what about this guy? This one shows, well, we have 1x negative here, but we also have an H plus, means that looks like this thing just went through hydrolysis. All right, so nothing has been neutralized. I'm going to say this is 0.1. Okay, and that is the last multiple choice question, and this is where we are going to stop for our review. And you can stop there too. Okay. Any questions, please let me know, and we would be happy to do whatever we can to make acid base work for you. Okay. Thank you.